All right, good morning. Let's begin. You have a quiz next time, and the coverage of the quiz is going to be from the material that was on the day of quiz 1 up until including today. And so you can look over the course schedule and see what the list of topics was. And so we've done some Excel stuff since the first quiz, and you won't need to use your computer to solve the quiz, but I may ask some questions that are related to Excel. For example, maybe like things having to do with the formulas or something similar. So you don't have to bring your computer to class next time, but that doesn't mean the quiz excludes anything having to do with Excel. Also, you now have your next homework assignment, homework 5, having to do with spreadsheet functions. Has anyone started on that already? Good. Getting the early start. I think probably even just from last lecture you could solve all of the questions on that assignment. You know, we did a lot of computer stuff last time. We're going to reinforce it today just to get some additional practice. Are there any questions on the announcements? Anything in general for the course? Let's take a look. I don't have it memorized offhand, but we can find it in the schedule for the course. And I happen to be logged in already, so let's see. The midterm exam is, all right, Sunday, October 18th. That's so small. Let me do this. There, that's better. Yeah, Sunday the 18th. So that's, you know, after we have a little bit of a long weekend. But the exam is going to include through Chapter 5, which we're beginning next time. On Thursday we're going to begin Chapter 5, and then that's going to be the last of the material that's included in the exam. Yes? Yeah, it's in class during our normal 50-minute class meeting. Other questions? Okay, so let's review some theory before we get into problem solving. So far we've been dealing with series and sometimes single amounts. And the way that we apply the formulas for a series or single amount is a little bit different. In a complex cash flow that has both, we ultimately have to combine when we're either discounting from the future to the present or compounding from the present into the future. And just to reemphasize the language that I used there, and you know, I've said it previously in class as well, let's say we have a cash flow diagram like this, and we make some deposits, and then we want to find out what's the value in the future. If we know some interest rate, let's say it's unknown, but in a problem statement it would be given. If we're moving things from the present or other future amounts in the cash flow diagram to even further in the future, so if you're moving things forward, that's called compounding. So let me write that, compounding. And then if we have amounts that are already in the future and we're moving it backwards in time to year 0, so we're trying to find out some unknown present amount based on amounts in the future, then that's called discounting. And in compounding, the amounts get bigger. In discounting, the amounts get smaller. And if you look at the factors on the table, so I've given you in-class exercise 11 today, and there's the 8% table on the first page of that. So for example, if you look at the F/P column, that's the second one right after N. you can see that the factors are getting bigger with each year. So that illustrates the effect of compounding. But then the next column over, the present worth column where it's P/F, you're finding the present value based on a future amount. Those factors keep getting smaller and smaller as n goes up. So the first column is the compounding column. The second column is the discounting column. And a similar thing is true with the A/F and the F/A. You know, the factors are either greater than 1 or less than 1, and which of those depends on if the amounts are being compounded or discounted. All right, so back to this idea of shifted series. Let's take a look at an example before we get going into the in-class exercise. Okay, we have a cash flow diagram where there is a series of annual payments, but those annual payments don't begin until year 3. So you can see in year 3 there's we make a payment of $5,000. Year 4 we pay $5,000, and so on. And then there's also a one-time payment of $2,000 extra. So the total amount that is outflow in year 8 is $7,000. But then in year 9, it's back to another $5,000 and so on. So what we need to do is this next cash flow diagram is showing you kind of in your mind. You don't have to actually write it on the paper, although you can. You can write the second set of years on the paper if you like. I sometimes just do it in my mind where I say, from the context of this annual series, year 1 is the first time you see the annual series. And so here is like a pseudo 0. Our real year 2 becomes like an imaginary year 0 from the viewpoint of this annual series. And so in the solution, what we're going to have to do is we're going to have to take the annual series to this pseudo year 0, and then we know that's actual year 2. Take it from year 2 to the actual year 0. And then since this is a one-time amount of $2,000, then we just take that directly from year 8 to year 0. We don't have to do 2 steps. We don't have to take it from pseudo year 6 to pseudo year 0. Does everyone know what I mean when I'm saying pseudo? It's just sort of like imaginary or fake, kind of like a synthetic, a second set of years that we're using only to refer to the annual series. Okay, so that's what this set of factor calculations is showing. It's showing we take the amounts to year 2, which is kind of like our imaginary year 0 on the context of A. So let's look at the factor solution here. They're saying the present value of the annual series is 5,000, so that's the amount, times the factor. So what's in the parentheses here just means the factor where you're finding the present value based on an annual series, 10%, and n equals 8. Let's double check n. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's 8 payments. It'll take it to this imaginary year 0, which is actually year 2. So we look up the factor from that, multiply it by the known annual series, and we get an amount. And now this amount is at year 2. And so then the second step you can see is they're finding the amount at year 0 by multiplying the amount at year 2 by the present based on a future amount. So it's kind of strange. We've got this in year 2, so that's a future amount that we want to take to year 0. So P/F, 2 years that we're doing it. Here's the factor. And then you can see the last step is just moving the single $2,000 payment over 8 years with a P/F, and then combining the two amounts together. So I hope that seems familiar from what we've done before. The same thing can be true with gradients, where we have to come up with a pseudo numbering system. Now remember, with a gradient, you don't actually see the extra amount until the year 2. And so, starting with the actual numbering system, here's 0, 1, 2, 3, 4, 5, and so on. It's increasing by amounts of 5, and there's an annual series that has a base of 60. And so when we see 65, that means that when that 5 kicks in, that's year 2. And you can see the imaginary numbering system that's shown here in light red. So this is going to be our pseudo year 2. So we're going to have to take the entire cash flow here to year 2 for the gradient, and then from year 2 to year 0. So the gradient is treated separately from some of the annual series. You know, here is an annual series that's going along at the same time as the gradient, but then we have these 2 extra 60,000s that have to be moved separately back to year 0. So here, in this bubble, you can see where it's saying P/A. That's just picking up these last 2 60s that weren't included with the first step here, where it was 8 years of the P/A and the gradient, moving that to 0, which is actually year 2. All right, so let's put that into practice with in-class exercise 11. You've seen this cash flow diagram before. This is the one that we had in class last time. I don't think we actually solved any numbers for it, though. I'd like you to, this is a 5-step problem. You know, the outline that I intended for last time was that there's 5 steps you need to go through to find the present worth of this cash flow diagram. So this time you actually have the 8% table there on the same page. So find the numerical solution to what is the present value. What's the value at year 0 of that cash flow diagram? And go ahead and work together on that, of course. It's always encouraged to collaborate on these. We have a quiz next time, and I want to give you the warning that you want to get as much partial credit as possible if you make a mistake. And I want to give you partial credit, but you have to help me out by writing as many calculations as you actually did. So show your work, because if you just have the final answer and the final answer is wrong, then there's nothing for me to give you partial credit for. But if you have other steps along the way that, you know, if you're showing me something right, then I can give you part of the points. So what I've tried to be doing here is show as much detail as possible. And by the way, the cash flow diagram's a little bit messed up. I got a new printer, and I don't know why it showed these extra lines. I think it's having its own ideas about the cash flow diagram, so I've crossed those out. It's okay if you do the you can do the gradient part first or the annual series part first. It doesn't matter whether you start here or here. Either one first is okay. It looks like what I did is I started with this section first. And so I was moving the annual series to year 1 here in this first step. I looked up the factor for that. So the value of the 11,000 in terms of year 1 was 28,000. And then I moved it 1 more year back to year 0. So here's the value. 26,247 is the value of this annual series in years 2 through 4 put into year 0. And that's a positive value because it's money that's coming to us. Any questions about step 1 or 2, moving it to the present? Maybe the trickier part is what happens here with the gradient. So what I did with the gradient section is I'm moving first the 5,000, the annual series, a constant 5,000. There's 1, 2, 3, 4 of those payments that we are making of 5,000 each. I move that to year 6. So here you can see P/A, I equals 8, N equals 4. I'm finding the factor for it, multiplying it by 5,000. So in year 6 is negative 16,560. And then I'm also finding the value of the gradient. Gradients are the tricky part because here's your 0 of the gradient. Here's your 0 of the gradient, which is numbered as year 6 on the cash flow diagram. So we see 0G in year 7, 1G, 2G, and 3G. So 1,000 is the value of the gradient itself, and I multiply by the factor, and it takes it over to year 6. And then I combine both the annual series, which was 16,000, and the gradient, which is 4,650. Combine those together, and this factor of 0.6302 is just discounting it from year 6 to year 0. So the final answer should be 12,880. So how hard will the quiz be? You should be able to do this kind of a problem for the quiz. Yeah. In step 3, I was doing this I was doing this part. So in step 1 and 2, I was dealing with this one. And I apologize that the cash flow diagram's kind of sloppy, but yeah, step 1, you see the amount there is 11,000. So that was dealing with this one. And so you're asking about the 5,000. That's because in step 3, I'm dealing with the annual series that's here. Other questions? All right. Yes. All right. So what I'd like you to do now is fire up the computer. You have a problem 2 on the back that I'd like you to get some more practice using the FV function. And that's the complicated one because NPER, which is the number of years that goes into the function, is different from the row number that you're on. You'll remember that we had 2 different time columns. The first column was year. What was the second column? Yeah, it was years until whatever we're interested in the future. All right? So remembering that, solve problem 2 using Excel. Yes, all of it. Problem 2. It's on the back page. Okay, so here's problem 2 that we're doing. Here's the cash flow diagram, moving it to year 16. I'm going to put the solution on the screen if you want to take a look. You don't need to write it, but the second one, no. 61? How'd you get it? Now it's right.
This was positive.
Oh, okay, perfect. Yeah. So now you just do equals sum and of the whole range, yeah. All right. That's it for today.